Hello friends, very good morning. The video tutorial that we are going to discuss today is about Maculapet's neuron, or in short we represent it as MP neuron. Okay, so basically MP neuron is mankind's first mathematical model for representing a biological neuron. Okay, if you learn about deep neural networks and all, then the most fundamental unit of that one is an artificial neuron or perceptron, we say. Okay, if you want to understand how this particular MP neuron works, that is being represented with this diagram over here, what we are seeing that we are having some specific inputs x1, x2, x3 and xn. These are different inputs that are coming to this specific circle. That circle is representing a neuron in this case, right? And we are dividing it into two parts. Part 1, that is being symbolized as G, is representing aggregation of all the inputs. Okay, so x1 plus x2 plus x3 till xn, we are aggregating it. And the second part that is being represented as F, that is basically used for taking decision, either this neuron is going to be fired or not, or if the output of this neuron is going to be 0 or 1. Right, so this is basically how MP neuron works. It get the aggregation of inputs and check some specific conditions and then take decision either should be fired or not. Right. So let's take an example of different inputs and outputs. Say we are having, I want to predict my own decision whether I want to watch a cricket match or not on TV. So the inputs I will have will be in Boolean forms. Like we are having 4 inputs that I am representing with x1, x2, x3 and x4, where x1 is saying that if this cricket match is a Premier League or not, or if it is a friendly game, or if I'm at home or not, or if the team that is playing is my favorite team or not. So these are basically 4 inputs and they are having some binary value, true or false, right? And my output variable will also be Boolean, like I will watch match or I will not. So 0 and 1, in that case we can represent it, right? So we are taking the inputs and output in Boolean formations. Now the inputs that we are sending are of 2 types. One, we are saying excitatory inputs, another we are saying inhibitory inputs. It is very important to understand the term excitatory and inhibitory. So if we are talking about inhibitory, that basically means it is completely decision making things. Okay, it affect the maximum on the decision making irrespective of other inputs. That is, if as per my example of watching TV, if x3, that is I am not at home, if it is true, that means I will never watch the match. Okay, so it is completely affecting my decision. So if there is any inhibitory input in the particular neuron and its value is true, in that case the neuron is never going to fire. So it is completely affecting our decision. On the other way, if I am saying about excitatory inputs, then they are not individually taking any decision, but they are helping in aggregation. Right? So they will be combined together, and then according to the condition, it will be decided either the neuron should be fired or not. As you can see here, what we are doing, we are getting the aggregation of I to n of xi. Okay, so if this is the function gx, it will be true if gx is greater than threshold, greater than equal to threshold value, and if it is less than threshold value, then it will be 0. So threshold is basically a particular value that we have to decide, and we have to check the specific value. If it is true, if it is greater than that value, then the neuron should be fired. Let us see how. So we are taking some example of Boolean functions using MP neuron. First we are taking the AND function, and you know that in case of AND, the specific condition, if x1 is true and x2 is true, if both the inputs will be true, then only the output will be true. Otherwise, in every condition the output will be false. So what should be the weight, or what should be the threshold over here, which will allow the neuron to be fired? When it is this one value is 1 and its value is 1, that means 1 plus 1 2. So if the total aggregated value is either 2 or greater than 2, then only we will allow the neuron should be fired in case of AND function for 2 inputs, right? Otherwise it will not allow to fire. Same for all, we know only one of them, either x1 or x2, any one of them is having a value 1, in that case the neuron should be fired. So now what we will choose the threshold value for this one is 1, because if this is 1, this is 0, no problem. If this is 1, this is 0, no problem. But if both of them are 0, then only the aggregation will be less than 1 and it will not allow to fire. right? Same we can do with other functions also. Now if we'll talk about geometric representation of MP neuron, so we are saying this specific representation is for OR function, and how we are getting the equation of that one is x1 plus x2 is equals to summation of this one, and that should be greater than equal to 1 in case of OR, that we have decided that the threshold value is 1. So the sum of x1 and x2 should be greater than the threshold value. So we can represent it like this one. We have four specific points 0 0 0 1 1 0 1 1, and there is a specific line that is intersecting between these 2 points 0 1 and 1 0, because what we have x1 plus x2 is equals to theta is equals to 1, that we can have a decision making condition, and this is the decision line but which is separating the specific parts into two different ways. All the points which are equal to or which are lying on this line or above this line, they are allowed, and the neuron will be fired in that case, and all others will not be allowed to fire the neuron. Same in the case of AND function, we are saying our threshold value is 2, and when we are having this equation, we are saying x1 plus x2 is equals to this specific value, and then there is a point 1 comma 1, that is the specific point which is in which this line is intersecting, and in that case again everything that is being below this, they are not allowed to fire the neuron, and everything above or in this line, that will be allowed to fire. So this is basically linearly separating our specific points into two parts, negative parts or positive parts, right? So in summary, we can say a single MP neuron can be used to represent Boolean functions which are linearly separable. Linearly separable means there will be a line that is separating the specific parts into two different ways, either positive and negative and so on. If we have more than 2 points, in that case we will separate it through a plane, or more than then we will have a hyperplane also. So guys, we have discussed all about MP neuron or macular pit neuron. Later on, because of some drawbacks of this one that we will discuss in next video, we have to move on to another concept of neural network that is called perceptron, and that is again we are going to discuss in next video. Till then, please like and subscribe. Thank you very much.